Morning. Uh, let's start the class. Okay. Right. In previous class, we have seen the different types of landfill which we are going to be taking. Right. Based upon that one, we have classified them as open dumping. Then you have basic landfills. Then you have engineered landfill, and you have a bioreactor landfills. So those we have already seen in the previous class, right? Okay, let us go with the engineer landfills and let us try to understand how that is going to be contrasting or how it is going to be having a difference with respect to the open dumping. See, as we have already said that when we are going with the open dumping doesn't require any preventive measures, whether by what you call it as dumping your waste. If there is some degradation of material which is taking place in a area or on a given land or on a given natural what you call it as valley section, if you are dumping the waste, we are least bothered about the process of degradation which is going to be taking place. The waste, how it is going to be degrading, we're not going to be worried. Neither we are worried about the harmful chemicals which are going to be developing and which are going to be forming in the leachates and going to be getting percolated within the ground surfaces, and there is no preventive measures to monitor and extract the what you call it as liquid and the gases which are formed during the process of what you call it as decomposition, right? But in our engineered landfill, we do take care of all these things, right? As we have seen in the previous class, when we are going to be laying a layer of what you call it as different layers or different layers of membranes, like different clay liners we are going to be laying, the only purpose is that whatever the harmful chemicals or the leachate which is going to be developed during the process of decomposition, that should not be getting contaminated or that should not be percolating in the ground and getting contaminated. This is the major differences. And apart from this, whatever the gases which are extracted or whatever the gases which are going to be developed during the process of decomposition, those can be taken as a form of energy conversion, right? This is the basic difference what you are going to be doing. Of course, comparing to environmental hazard, open dumping is going to be having much hazardous as compared to that of your engineered landfill, which is going to be having least worries in case of there might be some what you call it as failure which can be taken at due course of time. But comparing to your open dumping, this is going to be very much engineered and monitored, right? So we need to understand how we are going to be optimizing, how basically we are going to be differentiating this from what we call it as our general open dumping act, right? So you need to optimize solid waste management system, how we are going to be using. So when we are going to be taking open dumping with respect to an engineered landfill, the basic separation is we are going to be covering that in the layers, right? We are going to be covering the waste in terms of layers so as to avoid, right? So as to avoid the spreading of waste pathogens as well as the odor, right? See, this is what we are going to be doing in a open what you call engineered landfill. In open landfill, we don't go with this all these things because we are least bother how it is going to be coming, how waste is, how much amount of quantity of waste is going to be coming, what are the qualities and all. We are not bothered about. Simply we are going to be dumping. So we are going to be avoiding the spreading of waste, right? Like the when we are only giving a certain or giving a prescribed area or prescribed portion for waste, that waste that leads to avoiding the spreading of waste. Along that, no organisms which are leading to the what you call causing of diseases are not going to be hosting, right? Since the decomposition process is going to be taking place, there is a least chances that whatever the during the chemical decomposition, whatever the chemicals and microorganisms which are going to be produced, those produced are not going to be organisms are not going to be causing diseases because here we are not going to be giving them a chance to spread, right? Or to come in contact with anybody. So it leads to pathogens and also the odor. Odor is what the foul smell which is going to be generated. See, What happens in open landfill when you have open landfill? See, open landfill is simply thrown up, right? You're going to be simply throwing. We might be covering, and some cases they might not be covering, or they might not be covering at all. Open, they're simply going to be throwing. So this throwing, while the waste is going to be getting decomposed, whatever the waste which is going to be decomposed, or let us say this has been the waste has been thrown up to this point. There might be stray animals, right? There might be dogs, there might be other animals which can be coming, which can be just scratching the waste and spreading the waste. That is not going to be possible in cases of your engineered landfill, but there is going to be every possibility that, or it always happens in cases of your open dumping. Then the microorganisms or the organisms which are developed, which are going to be causing the diseases, are going to be easily spread with respect to the flow of water, rainwater, surface water, or underground water. They are going to be getting transmitted, or with the flow of air, they are going to be getting transmitted. And when it is going to be decomposing, of course, there is a huge odor which is going to be spread. So since we are going to be collecting that with the gas, in the cases of engineered landfill, that is not going to be happening. So this happens in cases of the basic difference between what you call it as our engineered landfill and in cases of our open dumping. See, these are otherwise advantages also. This in other ways, these are going to be advantages and some silent features or some what you call the basic methods what we are going to be using, or basic principles on which we are going to be designing our engineered landfill. So we need to remember this one to correlate those answers also, right? Then you have gas extraction. We have the process of gas extraction well in cases of our engineered landfill. Of course, we don't have anything in cases of our open dumping. Open dumping, simply we are going to be throwing that. Since we have a gas extraction well, which can be controlled and can be reused for biogas, mainly the carbon dioxide and the methane which is going to be generated, they're going to be used as energy production in the biogas plant. They are going to be used for energy production. Basically, we know that when the chemical composition is going to be taking place, there are large amount of gases which are going to be occurring. Of them, we are going to be extracting. Since we are going to be extracting, hence the proper use of your carbon dioxide and your methane can be done. So as to make sure that whatever the gas which is going to be emitted during the process is going to be collected and is going to be used for a proper energy production. Then we have a liner system, right? The basic advantage or the what you call it as the basic what you call it as component or basic principle what we're going to be using in our landfill is the liner system. See, these are the main components, because once we are going with the liner system, then only this liner system is making it possible. Making it possible to make sure that whatever the what you call it as the harmful liquids or the chemicals which are going to be generated during the process of decomposition, those are not going to be traveling, or those are not going to be penetrating in the ground, because this doesn't happen in cases of your open dump, right? The moment there is a waste, let us say there is a rainfall, today you have dumped the waste, in the evening there was a rainfall, so all the water which was rainfall which was occurred on the surface, now that is going to be transmitting, or that is going to be percolating from the waste. When it is going to be percolating, while the percolation, it takes washes all the waste which are there on the waste, right? All the harmful chemicals and liquids which are on the waste, they are going to be washed off, and they are going to be taken to the ground surface. And when it goes into the ground, when it comes in contact with the groundwater, of course, the contamination is going to be taking place. But in case of our in engineered landfill, since we are going to be providing the liner, see this clay, the compacted clay, what you're going to be using, that is also a impervious. It is not going to be letting to percolate any liquid within the ground surface. It do acts as a layer or as a liner system to avoid the percolation. First of all, we have a membrane, right? You have a geomembrane liner. This liner do avoid the percolation of water, and also along with it, this compacted clay which you are going to be putting, clay is impervious. It has a very less permeability. So this also plays a role in preventing the what you call it as the harmful chemicals which are going to be generated to percolate, so as to avoid the contamination of groundwater. Then you have a leachate system. In a leachate system, see, we know that we are not specifying what is the type of only one uniform waste which are going to be having. Of course, we are going to be having a composite waste. it might be comprising of different components. When the chemical reaction is going to be taking place, when it comes in contact with the different components, a chemical reaction, chemicals are going to be developed. These chemicals are going to be mixed with the water, either with the rainwater in cases of your landfills, right? Then as a liquid, it is going to be forming and it is going to be getting settling down to the bottom. In the engineered landfill, what we are going to be doing, we are going to be collecting them, right? We are going to be collecting them, and this leachate is collected at some unit and is going to be taken. If it is too harmful, depending upon the characteristic property of the leachate, a proper treatment is going to be done and it is going to be conveyed to a natural water source. So that once you give the treatment, the harmfulness or the what you call it as the intensity of harmful chemicals or harmful components present in the leachates is going to be getting decreased. But that doesn't happen in case of your open system, right? Simply whatever the leachate which is formed, it is going to be getting into the ground and contaminating the soil as well as the water. Here you have a leachate system where the collection and treatment is done of a fluid effluent, whatever the fluid which is going to be formed, that we are going to be giving the liquid of the leachates is going to be giving treatment, so as to make sure that whatever the harmful property of the or the characteristics property of the waste is there, that can be easily minimized. So this is basically the difference between your what you call it as our open landfill and open dumping and engineered landfill. Along with that, as we are repeatedly telling that we are monitoring the contamination. Of course, what you're doing, you are monitoring the groundwater also, because the quality, if the contamination is not there, the groundwater contamination is not there, of course the quality of water is going to be, or the groundwater is going to be good. Let us say here you have a groundwater table, right? At this area, this is the water table which you have, right? At this point, this is the water table. Let us say this is the water table. If there is no percolation or contamination of this water table, of course the quality of water is going to be good. But in cases of our open system, since you don't provide any liner and all, the contamination of the water is going to be taking place. Hence, we do monitor, right? In this system, in the engineered landfill, we do monitor. See, we have applied an engineered system, but we don't know that at what point, because of some unseen circumstances, there might be failure which is going to be taking place, and because of which the leachate might be percolating in the ground. So what we do, we monitor the groundwork, right? We monitor the groundwork so that we can understand whether there is any leakage or the contamination because of this landfill has been taken up in the area. That we are not going to be doing in cases of your open dumping. Open dumping, simply we are throwing the waste on a ground, right? So these are the major systems which are going to be differentiating between your landfills or open dumping and engineered landfill. Now you have basic landfills. Of course, all the landfills do have, but they are supposed to be designed with some principles or some basic necessities has to be taken. In your emergency landfill, or in case, let us say you are going with the quick dumping of a landfill, right? So if you are preparing for dumping a landfill, so these are the principles which you have to take into the consideration, right? So it says that the pit should be backfilled with excavated soil every day, right? Whatever the waste which you are going to be throwing, it should be filled, right? For example, today, let us say I have thrown some waste at this point. This is the ground. Now I have excavated this ground, right? Let us say this dimension is too large, right? This dimension is something like this, right? Let us say this is the actual ground which has been excavated. This is emergency landfill, basically when you don't have proper monitoring system, or let us say there is some part which is going to be used, or there is some issues which has been taken place. So they're going to be taking place emergency landfill or basic landfill. In that case, whatever the landfill which are going to be taking, those landfills, the pit should be backfilled with the excavated soil on day-to-day basis. See, let us say this is the amount of waste which I have dumped today at this point, right? Earlier it was empty. Now I have dumped this waste today. Once I have dumped this waste, on the same day, the pit should be backfilled. That means that I should be backfilling, or I should be covering this with a layer of soil. Each day on day-to-day basis, I have to cover. This is what they have done there. Today they have filled the waste, then they have gone for covering, backfilling with the excavated soil each day, right? Every day we have to take that one, and you have to make sure that there is some what you call it as covering on the top surface up to a minimum depth of 0.5 meters, which has been taken place. Basically, we go when these trenches are up to a depth of 1.5 to 2 meter. Only the height of excavation is restrained to 1.5 meters to 2 meters, over which you are going to be putting a 0.5 meters of covering layer or backfilling layer on the refuse or waste which are going to be dumping on day-to-day basis. So this process goes on continuing on day-to-day basis. So this is what you are going to be using, or you are going to be applying when you are going to be going for a emergency landfill or a basic landfill. So what happens in this case? Once this is filled, right? Today you have filled. After once you have filled, you have applied the backfilling, you have covered this one. Now this was on the day 1, this was on the day 2, and this is on the day 3. Today, this was day before yesterday, this was yesterday, and this is today. Right? This is how you are going to be doing. So day before yesterday we have thrown, we have covered with the backfill. Yesterday we have thrown, then we have covered with the backfill. Today we have thrown and we have covered with the backfill. So this is how you are going to be taking the use of or the method of disposal when you have a basic landfill or emergency landfill. See, cases come where you are supposed to have a landfill where you don't have any proper allocation of your landfill and all, but the dumping becomes very much important. It might be because of the availability of what you call it as unavailability of the waste in the area, in the nearby disposal area in the nearby locations, or to some unseen circumstances the dumping has there was no landfill, so we'll go with some type of basic landfill and all, right? But before we take any landfill for this one, the site which we are selecting, this site should be agreed by the local population and also the authorities. Like basically what happens, let us say if this is my district, let us say I'm drawing a rough diagram of some district, right? Let us say this is my district. Basically what we prefer, if this is the area where the amount of waste is being developed, so I will not be dumping the waste or putting a backfill in this area, right? We will be selecting landfill to some area where the amount of population, or the area where you don't have less amount of population at that point. So we have to make sure that depending, like if you take the landfills of Bangalore don't have their landfill in the city because of the cost of the land. They have their own landfill at Tumkur district, right? That depends upon the land cost of land and other factors also. So whenever you are going for a emergency landfill, you have to make sure that it should be agreed by local population, because see, why? You are generating waste and you are throwing it to some other place where already some population are going to be staying, so it becomes a very undigestible condition for this one. So it has to be approved by authority as well as the local population. Until and unless those sites should not be finalized, right? Those sites should not be taken up for the dumping. Then we always want that we want to avoid the spreading or the spreading of waste, either because of animal interferences or because of the pathogens or whatever may be there. So in that case, what we want to do, we want to make a proper fencing system so that proper monitoring and proper disposal can be done, so that the stray dogs and the other animals should not be coming to the area and the spreading is going to be taken up place, or it should not be what you call wrongly interpreted with some other thing for the locals who are going to be visiting the area. For that reason, we want to make sure that these whatever the landfills we are going to be selecting, it has to be fenced properly. Temporary fencing has to be done so that it can be safeguard from all the other visitors, the unwanted visitors who are going to be visiting to the society. And at least it says that it should be 1 kilometer away from the nearest population. It should be nearest area or the amount of population which is going to be present. It should be at a distance of how much? 1 kilometer, so that it should not be making some unhygienic condition for the people who are staying closest to them. And also it should be in the downwind direction, that it should be at the lower elevation or in the direction where the winds is going to be flowing towards the landfill. So in those cases, we are going to be going taking these conditions into consideration. We are going to be selecting a basic landfills or emergency landfills, right? Okay, now then we need to understand the basic principle, right? If you have an engineered landfill, now how an engineered landfill is going to be working, we need to understand the basic process or basic purpose, how we are going to be designing this one. See, the key component on which we are going to be what you call it as depending to have our landfill into the consideration is that the first one is that we want to have a capacity which is going to be planned, a site which is going to be having or which is going to be established with respect to the design criteria in which it should fulfill the capacity which is planned, and the site chosen should be based upon the environmental risk assessment. Environmental risk assessment means what? See, okay, let us first understand what do you mean by capacity planning. Just a moment. Okay, I'll take an empty page, right? Okay, right. When I'm talking about a capacity, let us say this is the area of landfill which you have selected. Let us say this is the three-dimensional image I'm going to be giving you, right? Okay. Let us say this is the pit. This is the dimension, or this is the amount of area which has length, which has breadth, and which has height. We don't know what it is, but when we are designing this, when we are designing this, we want to make sure that the breadth which we are going to be keeping, the depth and the length which we are going to be keeping for the area, this is designed. Let us say for 10 years. For 10 years, let us say this landfill has been decided for, let us say, Bhalki Taluka. I have decided for Bhalki Taluka. Let us say Bhalki Taluka or Bhalki is generating 1 ton of solid waste every day. 1 ton of solid waste every day. So I want to make sure that if the rate of generation is 1 ton, with the increment in the rate of generation at a percent of 1% or 1.2% or 1.5%, let us say into 2021, right? It is generating a waste of 0.1 per day. In 2022, it might be go up to 1.1 or 1.2 with any 1 or 2% in the generation rate. Let us say like this, I'll be designing, I'll be understanding that for this many years, I'll calculate 1 ton for every day, then how much for 1 month, then how much for 12 months, then 1.2 for 1 month, then for 12 months, then 1 year. Like this, I'll calculate the waste which is going to be generated for next 10 years. Based upon this 10 years, based upon your amount of waste even which is available after segregation and after giving all the separation part or giving proper compaction and part, I will analyze that the quantity of waste which has been generated for 10 years, to dispose that one, how much land is going to be required. The first and the primary design is based upon the capacity. Based upon this, I shall be designing the capacity of this land. Then I'll be deciding the length, the breadth, and the height of the landfill. So that is what you're supposed to do. That is what you're supposed to do in cases of your design principle. You're going to be first planning the capacity, and the site is chosen based upon the environmental risk. See, if you have a stream over here, let us say it is not properly lined, or if let us say at some point of time there is a liner system fails, then the contamination of the natural water source is going to be taking place, or it is going to be leading to some harmful causes if you have a water source very nearby, or let us say if you have a pond, or if you have a lake, or let us say you have a stream which is going to be flowing, or you have a what you call it as at the time you have a forest and all that, the environmental impact is going to be taking place. So we assess, we make sure that this all these points are going to be considered. Then we are going to be locating the location of your landfill. Then the gas is flayed, or it is used for energy purposes. Flayed means what? When I dispose, I'm going to be spreading them on a larger area, or gap is going to be made exhaust on a higher elevation, so that it gets mixed with a huge amount, or it is going to be spread off openly, so that the odor can be reduced, or it can be used for energy production. Like you have free CO2 and CH4, methane and carbon dioxide, based upon their characteristics we are going to be using. Then we have a gas management system. we have to design the gas management system, which is going to be analyzing the amount of gas which is going to be generated, and based upon this, what is going to be the methods which are going to be taking place, or what do you call it as different gases which is supposed to be taken for the energy extraction, or whether of the given gases how much should be extracted and how much should be flayed up, that we design. Then we also monitor the gas monitoring probe. Gas monitoring probes keeps what do you call it as monitor, or keeps a record, or keeps an idea of how many gases is going to be generated, and how this contamination of this gas is going to be leading in the ground surfaces. That you have an extraction well. This gas extraction well is nothing but the pipe from which the gas which are going to be developed during the process of decomposition, the gas which is going to be generated are going to be getting extracted. Then you have surface water control system, or we are going to be putting us what do you call it as on the side we are going to be providing the drain, so that whatever the rainfall which is going to be taking place, the water which is going to flow, those are going to be removed up. So even we are going to be designing the surface water system so as to analyze, so as to make sure that amount of water which is going to be accumulated because of rain or any other purposes has to be removed from the landfill. Then you design the cap system. Cap system is nothing but covering the top surface of the landfill. That again do depend with what quality of material we are going to be. See, if let us say if you have done everything properly, but if you have not covered it with the proper method or proper system, again the vertical spreading of the waste is going to be taking place. Odor and pathogens or the microorganisms which are going to develop, they are not going to be controlled of if the cap system is not designed properly. So we do take care of that cap monitoring, cap system, cap covering system. Then you have leachate management system. We know that when you have a waste, this waste is of composite materials, or we have different materials which are going to be there. So all different materials will be having different characteristics, property, and all because of which a huge complex leachate is going to be generated, which is going to be having to harmful properties. So we are going to be first collecting them, right? A proper means or proper method is going to be applied by regular interval. You are going to be putting the pipe so that the quantity of leachate which is going to be generated can be easily removed. Once it is removed, it is brought to a system wherein which we are going to be treating, and you are going to be disposing or further sending them for the what you call it as conveyance system or the disposal system. Then you have a liners, right? These liner systems are nothing but it prevents the contamination of water. Then we are going to be designing this liner system also. These liner systems are designed based upon the weight, based upon the area, based upon the characteristics property of this liner. See, if we have the what we call it as our GT, you have geotextile geomembranes. They do act as a separators, and they do act as a filtration mediums. Here they are going to be acting as a separator material, which are going to be separating the waste as well as the soil. So we are going to be designing this liner system, whether we are going to be using the geomembranes, geotextiles, or some clay material, so as to provide the percolation of the waste or the leachates from the what you call it as bin to the landfill to the ground surfaces. That's what you're going to be designing. Then you are going to be monitoring the downward ground monitoring well, which is going to be provided on each end. One is going to be upgradient groundwater system. Then we are going to be having the ground water system, whatever the water system which is flowing inside from top surface to bottom surface, that we are going to be monitoring. Then the water which is going to be in the ground, there is going to be extracted and is going to be monitoring. Then we have waste and daily recovery, the quantity of waste which is going to be taken. Even you have to design that how much amount of waste has to be taken, what should be the characteristic property of those waste which are going to be collected, right? Then you have a bioreactor. The last type of your landfill is nothing but a bioreactor. So what do you mean by bioreactor? Bioreactor is nothing but a system where we are going to be what you call it as intensifying the process of decomposition, right? Either by adding liquid or the gases, that is by adding your oxygen, right? We are going to be intensifying the process of, or we are going to be fastening the process of decomposition. That's what we have with the bioreactor landfills. Since we have an anaerobic bioreactor, hence it doesn't require any gases or what you call it as there is no oxygen which is going to be required, right? An aerobic bioreactor wherein which you are not going to be requiring any oxygen for the disposal process, right? So in anaerobic you don't need any oxygen, hence you can cover this one. You can have aerobic bioreactors also. We supply the gases wherein which the proper application of the gases leads to the proper process or the fastening of the process of the contamination, right? Okay. So what we do this in this one means we are going to be accelerating the biological decomposition process by organic fraction. By putting the water, they are going to be getting crushed off, or the decomposition process is going to be what you call it, it is going to be increase the speed at which the decomposition is going to be taking place. That is going to be getting speeded up, because of which the acceleration is going to be done in our bioreactor landfills. Then we are going to be promoting the conditions wherein which the necessity of microorganisms, by that is what we are going to be doing by applying or by conveying the water into the waste. By applying the moisture content, the microorganisms are going to be getting more activated, and the process is going to be getting faster. So we are going to be adding the liquids such as leachate, stormwater, or sludges. Then whatever the gases which are going to be collected, those gases are going to be taken for the electrical energy, for the production of electrical energy. Then you are going to be designing the liners, right? Liners which are going to be used for covering, right? Liners which are going to be used for covering the leachate system, which we have seen, and also the groundwater monitoring system. The systems might be aerobic. Here you have anaerobic bacteria, anaerobic bioreactor, because you are not providing the oxygen over here. But in some cases, we are going to be providing the oxygen where you are going to be having an aerobic bioreactor. Then you have anaerobic bioreactor. Then you have the combination of aerobic and anaerobic bioreactor, wherein which you are going to be partially putting oxygen and partially you are not going to be supplying the oxygen, because of which the decomposition is going to be taking place. The active decomposition or the faster decomposition of the waste is going to be taken place. Then you have the facultative bioreactors, which occurs optionally in the circumstances rather than nature. Other than that, you yourself generate some unnatural process, because of which the contamination, the speed in the decomposition is going to be taking place. So how a bioreactor basically works, this is how we are going to be putting that. The landfill, see, you have a composite clay which is going to be laid and which is going to be lined. Then you have this thin layer of black sheet, that is nothing but your liner, over which you are going to be putting the clay, right? Sorry, boulder particles which are going to be segregating. Then we are going to be putting the surface, what you call it as the liners, again a composite liner, over which you are going to be putting your waste. This waste, while putting this waste, we are going to be providing some pipes. These pipes are going to be conveying the water from the liquid storage, or it might be a water, it might be a leachate, it might be a sludge. So because of which what happens, the decomposition process of our waste which you have taken is going to be getting speeded up, right? The microorganisms are going to be promoting the conditions wherein which the decomposition is going to be increased. Then during which whatever the gases which are going to be generated, those gases are seen in yellow pipes, those are going to be collected and they are going to be converted for the production of other energy or electricity. This is what or how we are going to be having a bioreactors. Now the treatments, see, in all the type of what you call it as our landfills. Okay, just a moment. Leachate is going to be generated, right? See, depending upon this one, leachates do have a very harmful properties or harmful chemical compositions, right? So a treatment has to be given to those leachates, right? So without proper cleaning, leachate will cause n number of environmental problem. So a potential treatment has to be given. So what we do, we are going to be recirculation of leachate through the landfills. So what happens? Certain harmful chemicals which are going to be present in the leachate, they helps in by doing this one. When you are going to be recirculating the leachate in the landfill, what happens? The microorganisms are going to be promoting to decompose at decompose the waste at a faster rate. For that reason, what you call it is recirculating, because of which the harmful properties of this leachate is going to be getting reduced. Then we are going to be disposing off from the site to the sewer for a proper treatment, wherein which you are going to be adding admixtures. Admixtures might be in a form of your domestic sewage. Domestic sewage means waste from your kitchens, waste from your bathrooms, or from the toilets and all. Those waste or domestic sewages are going to be added so as to minimize, also as to degrade the property of the what you call it as the harmful property of our leachate. Then either you're going to be giving some physical and chemical treatment in the area so as to make sure that the intensity is going to be getting reduced. Simply, if you have a milk, right, if you want to reduce the what you call it as the portion of the milk, what do? You add the water. The intensity of the water, the amount of water you add more, the milk is going to be getting degraded, right? Similarly, a thick leachate is going to be getting degraded by adding some admixture that might be your domestic sewage. Then you're going to be giving certain physical and chemical treatment. Then the other thing is that by giving a membrane filtration. Membrane filtration means what? When any liquid or any harmful chemical which is led to what you call it as filter through different medium, all the different harmful chemicals are going to be getting restrained, or they are going to be getting deposited on different layers. This is what are different membranes. This is what we call it as membrane filtration. We go with the membrane filtration method. Then you have a reverse osmosis method, right? We know the osmosis method, that is percolation is nothing but your osmosis method. We go with the reverse flow of water or reverse osmosis method, because of which the intensity of the hazardous intensity of the leachate is going to be getting decreased. Then you have aerobic biological treatment, wherein which you are not going to be providing any oxygen. Even you provide some oxygen so that the characteristic property of the leachate is going to be getting decreased. But the most commonly used method is by constructed wet landfills. Wet landfills means what? The area where you have always a natural stagnation of water. That is what we call it as wet landfills. Area where you have a lot amount of surface water. What do we do? See, if this is the surface water, let us say, on some area, on some location, if this is the water, right? If this is the quantity of water, let us say this quantity of water is about 10 QMC or 20 QMC, 10 QMC water is there. To this, if I add 1 liter of what you call it as leachate, this is not going to be degrading the property of water, right? So what we do in a wet landfill where we have a good quality of water, or where we have sludge, where you have waste, or where you have any other water, so we are going to be putting that leachates into this wet landfill. So because of which the hazardous property of your leachate is going to be getting decreased off. Then we are going to be collecting them properly. The basic thing is that we are going to be collecting them properly. See, this is how we are going to be collecting this, right? We are going to be using this with respect to the drainage pipes. We are going to be taking them, which is going to be laid at a slope of 1% of slope, depending upon the width to height. We are going to be laying the slope. This is our what do you call it as waste, right? So this waste is covered with the liners, like it might be clay, it might be your geotextiles or geomembranes. Then we are going to be putting the soil. The soil is led with some aquatic plants and all. So when we pour the plant, right, water to this plant, this water from the surface with the property of your say what you call it as gravel and sand, they are going to be percolating on the waste. This waste is going to be getting purified when it comes in contact with the surface water or the water from the aquatic plants. Then it is going to be taken place. Or even in this case, we are going to be putting our leachates also. So the harmful property of the leachate is going to be getting segregated. This is what we go with, what we call it as membrane filtration process, right? Okay. Then we have what we call it as treatment and health aspect of different types of landfill, what should be treatment if we don't do, or if we use certain amount of treatment, what is the impact? That is what we call it as treatment efficiency. You need not to remember a full book on this one. Simply a diagram can show, if I have open dumping, if I have a basic landfill wherein which I'm going to simply dumping that one, and that is going to be covered on day-to-day basis. If I have an engineered landfill, if I have a bioreactor landfill, what is going to be the impact, or the efficiency of the treatment is going to be impacting the health of the human? Then this is what it shows, right? I hope you can understand, right? It is explanation, right? How? See, as we are moving downward, right, the hazardous effect on the health is going to be getting decreased, right? If you are putting the waste on an open dump, it is too hazardous for health as well as for human health as well as for environmental. But if you use some basic landfill, there might be some less effect. Let us say if this is affecting 10 peoples, this might be affecting 9 peoples. But you have an engineered landfill. See, engineered landfill, they do have less effect on the health of human, but on the environmental effect, it is going to be affecting a lot, because we are using the areas, right? You are using the areas. If you are not using, if you are using a barren area, that is going to be okay. But if you are using a good area which is good for plantation or for agriculture and all, those areas are going to, those a good land is being converted to a wasteland, that is going to be affecting the environmental. So engineering landfills do affect, but intensity of effect, if not monitored properly, right? If I'm not monitoring properly, what happens? I do have a hazardous effect, but if I'm monitoring it properly, the effects are going to be less. Whereas a bioreactor landfills, where I'm going to be intensifying the process of decomposition, so it is going to be too ecological, or it is going to be too less hazardous for the human health as well as for the environmental. So this is how it is going to be doing on the dangerous scale. Open dump is going to be too dangerous compared to basic landfill. As it goes from basic landfills to engineered landfills, bioreactor is going to be less effective, right? Less ecological effective efficiency is going to be taking place. So you know that the reason why we are going to be calling open dump is that, because in that the process of decomposition is very slow. You have the spreading of waste, that as I told you, because of the regular visiting of the animals to the area, right? The spreading of waste, pathogens, orders are going to be taking place. There is no liner, there is no cover. Percolation is always going to be taking place. But whereas in a landfill, the decomposition is going to be proper, but the cover avoids the spreading of what you call the waste and breeding of insect. But leaching will occur. Leaching occurs. Leaching leads to contamination of soil as well as water. Here you have advanced decomposition, wherein which you are going to be covering with the liners, leachate. The stormwater and gas management system are provided. So hence it is going to be having a very good efficiency. But when in a bioreactor landfill, you are going to be accelerating the process of decomposition. See, since I am decomposition here, I'm not going to be monitoring the decomposition. Decomposition might be taking any amount of year, but in the accelerated decomposition, since the intensity of decomposition is being used, I can reuse this landfill, because whereas I cannot do the same thing when the engineered landfill is going to be taking place. Hence it is going to be becoming more and more ecological efficiency. Then the point comes, how you're going to be monitoring and maintaining these landfills. Of course, it is going to be very, what you call it as a typical and very sensitive operation system. Hence it requires operation requires very efficient methods. Hence it is going to be too harmful and too what you call it as dangerous. It requires a proper and dedicated management system, or the people who are involved, those are supposed to be too knowledgeable or too skilled, and they should be very dedicated people who are going to be operating. Then the waste has to be covered on each and everyday basis, because what all we are doing is with respect to the waste. If this waste is not covered each day, of course, it leads to the spreading. And the proper leachate management system has to be done. We know that it is going to be very, very headache or very, very hazardous chemicals which is going to be developed because of the decomposition. Hence, a proper management system with respect to the leachate has to be done, right? Leachate has to be given with the proper management system. Then what you call it as your top portion is there. Those portions should properly be covered. The reason why we say this one is that it resistance to erosion, because the cover must be so strong that there should not be leading to any erosion. Because if you are not providing the covers properly, if let us say, if this is your landfill, engineered landfill or whatever you have, when it is going to be covered, whatever the topsoil if you are putting, this topsoil should be restrained, or it should be having a resistance against the erosion. Because if the soil is getting eroded, what happens? The water directly comes in contact with the solid waste. It is going to be leading to again disasters, right? So hence we want to make sure that whatever the top covers we are going to be using, they should be capable of restraining the erosion. Then once the capacity is reached, the bottom cover should be controlled regularly to avoid the toxic effluent and emission. That's what we have to do. We have to keep on monitoring the waste for a given time once the landfills are going to be filled up. Then the bioreactor landfills, of course, it do requires more complex set of operation and management system. Hence, we have to make sure that these operation and management system has to be carried out or has to be taken up properly, because we know that we are supposed to intensify or accelerate the decomposition process. Hence, we have to make sure that whatever the landfills which are going to be using, it should be have a complex operating and management system. Then we know that landfilling is one of the most and predominating what we call it as disposal methods which are going to be using these days. Hence, you do have some methods or some wider applications which are going to be applied, but they do depends upon what? Depends upon the community. Basically, if you are doing better management system, this better management system do requires a proper knowledge with respect to finance or with respect to the standard of the community, depending upon the community. Like community financial knowledge and interest. Community financial knowledge and interest means what? See, if you have a country, if a country is financially weak, it cannot be allotting sufficient finance for proper management system, right? If it is not developed, it doesn't have any knowledge of the hazards which are going to be forming. Hence, it cannot be done, and it should have the interests, right? They should be very faithful towards the ecological balancing system and all, because of which it do depends upon the community, city, and the system which you are going to be using. Then there should, of course, at any point of time, if I'm using the landfill, there should be sufficient land which should be available. Because, of course, if the land is not available in landfill, then you cannot have any area. If you have a highly populated area or highly population in the city, then you have to select some more area for the landfill to some others community which is not going to be reliable. Then compared to other discharge possibilities, costs are lower, right? The other methods or the means which are going to be taking in this, the cost is going to be lower, but only the landfill should be lined, correctly covered, and maintained to avoid the contamination of health risk to both environmental as well as to the human being which is going to be remaining. So remember, the best method to reduce the waste is either you reuse or recycle as much as possible. Because if you are putting the cycle properly, what happens? The amount of waste generated is going to be less. If the amount of waste generation is less, the disposal is not going to be a issue. But if you are not recycling and reusing your waste, then the waste generated is going to be large, and this large waste generation might not be suitable for management system. As I told you, these landfills to have some advantages and to have some disadvantages. Let us go with the advantages. Further, we'll go with the disadvantages. Advantages are what? It has a effective disposal system, wherein which it is going to be well managed, well taken care of. Sanitary system is more effective, of course. A sanitary disposal, which is going to be having a huge amount of order and huge amount of spreading of waste, it is going to be giving a constraint condition or constraint situation wherein which it can be managed very effectively. Then you have energy production option, where the fast degradation for the design bioreactor landfills are going to be taken place. These are going to be basic advantages which is going to be taking place. But disadvantages is what? If the amount of the waste which is going to be generated, if it is not recycled, if it is not reused, or if it is not separated, then the amount of waste generated produced is going to be large. If the amount of waste generated is going to be large, then your landfills are going to be quickly filled up. If the one landfill fills up quickly, then you have to go for selecting or searching the other landfill, and you require a larger area for disposal compared to other systems, right? If you're not sealing, of course, there is always a chances of groundwater contamination of soil and water if the liners are damaged at any point of time during the complete disposal process. Of course, you required lands, hence the cost is going to be high. If management is not proper, of course, we know that the operation and management process, we have seen that we required a proper management system. Then the degeneration or it comes to a situation wherein which you have to again open the landfill and you have to shift the waste which is going to be generated to some other landfills or some new landfills if the management is not going to be taking place. And after the end of disposal, the landfill still needs, like still, even like see here, we are having a monitoring system of how much 50 to 100 years, right? We don't know how many of individuals who have designed whether they will be alive or not, but you have to monitor them. This system, this is the basic disadvantages of our landfills. Okay. Switch. We wind up our class. So, guys, go through what all has been told: the advantages, disadvantages, figures, and principles, the component parts of landfills. Very much important. Okay, now, right, guys.